Hello everyone, myself Nisarg Patel, and today we will go through the assignment 1 of applied machine learning. So let's get started with that. And first and foremost, we are dealing with the fashion amnest dataset, which is provided by Keras, and we will predict what kind of cloth image is that, or whether it's a pullover or trouser or something else. So first of all, we are importing different libraries to work with the assignment. The first and foremost is the fashion amnest, the data self itself, then the utilities from tensorflow.keras, then toCategorial from keras.utils, and finally the matplot library because we need to show some images and graphs as well. The first thing we need to do is separate the data set into training and testing models. And for the training models, we will define train label images and train labels. And for the testing section, we will define test images and test labels. And using the load data and to get all the data from the fashion amnest and providing and categorizing into train and testing parts. In the question 1, we need to show the dimensions of train images, train labels, test images, and test labels. So for that, I have used the shape property, which will give us the dimension. As you can see, the train images is 60,000 images, and each one is 28 by 28 pixels. The train labels are 60,000. Testing images are 10,000, and each one is 28 by 28 pixels. And test labels are also 10,000. In the second question, we need to show the length of train labels and test labels. So I have used the len method, which will give us the training labels as 60,000 and test labels as 10,000. Moving on to the third question, we need to show some of the training and testing labels. In this case, I have shown just the first 5 labels, and we are defining as from the first index till the 5th index, which will give us the index of first 5 labels. Then in the fourth question, we need to show the digital content of the image at index 5. So we will simply write train images and in the square brackets 5, which will give us the digital content. The digital content is 28 by 28 elements of array, so 28 rows, and each one is 28 elements, and all the elements are between the range of 0 to 225, which is the color range in the RGB, because each cell or each element is defining the color or the color of the pixel in the images. Going forward to the question 5, we need to plot the image of the index 5 in training data set. To make it more clear, I have also used the axes and the figure, and we are using the IMShow method to show the train images of index 5, and using the color gradient as gray, CMap equals to gray. And if also just to make it more clear, I have set the title as well, and showing the plot by the show method, we will get something like this image, which is the image at index 5. As you can see, it starts from the pixel 0 to 28, both from height and from the width perspective. Talking about the sixth question, we are asked that what is the label for index 5 in train label. So the train label in the square brackets 5 will give us the label for this image. So it says 2, and in the fashion amnest data, the number 2, it belongs to the pullover category. So this cloth falls under the category of pullover dress or pullover clothes in the FashionMnist dataset. Now from the seventh question onwards, we need to do the same thing as we did earlier, but for the 500th index. And in this one, we will be using the testing dataset. So test images in square brackets 500 will give us the digital content. The same thing and nothing complicated. 28 by 28 pixels. Each one is 0 to 255. Then talking about the question 8, we need to show the image in the testing image which is at 500 index. Again, doing the same thing as explained earlier, we will get the image, the testing image which is at index 500, and this is also the 28 by 28 pixels. Now we are asked what kind of cloth is that. So to get what category is that, we will be using the test labels at index 500, which will give us again 2. So 2 means the pullover category in the FashionMnist dataset. So the testing image and the training image, the both are pullover category as seen by the image. Now in the 10th question, we need to import the models and the layers from Keras library. So for that, we will do from Keras import models and from Keras import layers. In the 11th question, we need to define a sequential model and call it as my network. So we will define my network, which is equals to models.sequential. Going to the 12th question, now we need to reshape the images from 28 by 28 pixel to one column with 784 neurons by using the flattening method. We can use the any method, one from the book or one from the video. In the first section, I have used the method which is provided in the book, and the one which is provided in the video I have just commented out, but if you want you can try that as well. So we will do training images is equals to train images dot reshape, and we are reshaping all 60,000 images with 28 by 28. Yeah, so it will be something like the 28 by 28, which is horizontal and vertical, it will all be a straight line with 784, because 28 by 28 is equals to 784 neurons. To verify that we reshaped it correctly, I have used the shape property. As you can see, 60,000 and 784. 784 is the column and 60,000 is the row. In the 13th question, we need to normalize the image by dividing 255. So why are we dividing by 255? Because the maximum of the element is 255, and we are dividing it to make it a number between 0 to 1, because the machine learning models works best for the numbers between 0 to 1. So for that we will convert the train images and testing images from the number 0 to 1 by assigning the float 32 as the data type and dividing by 255. And just to clarify, we have done correctly. I have shown the first the train images which is at the index 0. So as you can see, all the numbers are between 0 and 1. Now going to the number 14th, we need to add one hidden layer that has 512 neurons using ReLU activation function. So for that we will use the add method. So my network dot add, and then what we need to add, we need to add a layer. So we will define layers, and for the hidden layer we will use the dense method. So layers dot dense, And in the dense method, first we need how many units or how many neurons we need to pass. So in this case 512 neurons, so 512. Then the activation, what kind of activation we want, so we will use the ReLU in this case. And then the input shape, which is 28 by 28. Then moving to the question 15, we need to add another hidden layer, which is 128 neurons, using the ReLU activation function. Again doing the same thing, mynetwork.add layers.dense and 128 neurons and activation as ReLU. Now we need to add the last layer as 10 neuron dense layer that uses the softmax as the activation function. And we need to answer why we use softmax for the last layer and why does it work under the hood. So again doing the same thing, dot add method to my network and then layers.dense, defining neurons as 10 and activation as softmax. So why do we need softmax? So here I have written a full descriptive answer why we use the softmax. So the last layer is the softmax, which provides a probability distribution and aids the software in making prediction with confidence. The softmax function takes a vector as input and returns a probability distribution across the classes, where the probability of each class is added up to equal 1. Each element in the input vector is exponentiated, and after that the vector is normalized by dividing it by the total number of exponentiated elements. A vector of values between 0 and 1 that add up to 1 is created as a result. So we utilize the softmax activation function in the last layer to generate a probability distribution over 10 classes, because in the FashionMNIST data there are 10 different categories. Now in the 17th question, we need to use two settings for the compiler and run them separately and see what's the difference. So for the first one, we will set the optimizer as Adam, loss as space categorical cross entropy, and matrices as the accuracy. So for that we will use mynetwork.compile and setting optimizer Adam, loss as sparse categorical cross entropy, and matrices as accuracy. Now in the 18th question, we need to find the pattern using the fit model, and for this the epoch needs to be 10. So we will use the fit method and passing the train images and train labels, and epochs equals to 10 because we need the 10 repetition for the prediction. So as you can see, it starts from epoch 1 till epoch 10, and with each repetition the accuracy increases, so from 0.8285 to 0.9154, and the loss decreases from 0.47 to 0.22. Now changing the optimizer and the loss. So for the second one we will use the optimizer as RMS prop and loss as categorical cross entropy. For this case we need to use the two-cut categorical, which converts a class vector to a binary class matrix for the train labels and the test labels. And again doing the same thing, mynetwork.fit with the epochs 10. In the 19th question, we need to compare a FashionMNIST with what we have learned in class using the regular MNIST. So the regular MNIST, it's a number from 0 to 9, but here in the FashionMNIST it is an image of different clothes. So FashionMNIST, it's kind of more challenging and more complex picture as compared to the regular MNIST. For the difference in the accuracy, the numbers were more accurately predicted, as compared to the clothes, because as said earlier, the clothes images are more complex than the number ones. For the clear description of the answer, I have written here. In the last question, we need to evaluate the achieved accuracy and loss over the test images and labels, and we need to find if there is an overfitting or not. So for that, we will use the dot evaluate method and passing test images and test labels to get the test loss and test accuracy, because the accurate method will return the test loss and test accuracy. So in this case, the accuracy is around 0.8894 and the loss is around 0.5864. For the question, do we have overfitting? In this case, we don't, because the accuracy is more than the loss. So we don't have the overfitting. That's pretty much it for this assignment, and see you all in the next assignment. Till then, bye bye.